Two questions. That one is about methane, which I didn't talk about, and two is about increased cloud cover. So let's deal with both of them. Methane is a real problem. Methane comes out of the permafrost as it thaws. Methane, get some of my eye, excuse me. Methane comes out of the seabed as it gets warmer. There's a slushy frozen methane underneath the seabed, the methane clathrates or hydrates, and as they melt, it releases methane, both those things. And methane's a problem because it's much more potent than carbon dioxide as a greenhouse gas. Pardon? Well, okay, can a bubble explode? Yeah, but that's not our fear here, okay? So you can keep throwing facts in, but let me just try and answer your questions, okay? From a greenhouse gas standpoint, from warming the planet, methane in concentration can explode, but that's not how it's getting out of the ground or the seabed, okay? So it's different issues. It comes out of landfills, it comes out of a lot of places. But methane is tens of times more potent than carbon dioxide as a greenhouse gas and trapping heat. So it's a problem. And there's a huge quantity of it. I may just have to go. Methane is a big deal. And the problem is methane, even more than carbon dioxide, we can't calculate. And the reason is because, as I think you're alluding to, there's so much methane frozen or in the slushy ice or in the permafrost, the frozen earth in the north, and as the planet warms, it will come out. We really can't predict how much, how quickly. But it's a bigger problem because it's so much more potent. But because there's no way to calculate how it's going to come out, it's often left out. But the fact is, it gets us right back to the same basic issue. We need to slow the warming as much as possible. Because whether the methane comes out over 500 years or 5,000 years is frankly an unknown. So let me just leave the methane there. The clouds, the gentleman raises, is also a valid issue. As the oceans warm, there's going to be more moisture, which is going to turn more into clouds. Now, the dynamics of clouds turns out to be very complicated. It probably stretches our ability not only to model weather, but even computationally. Clouds look so pretty and simple, but the calculations of what happens with clouds turns out to be really leading edge stuff. And how we're going to get more clouds or less clouds or where they're going to be or what they're going to do to trap heat is something that scientists are going to keep working on. As an example, until last summer, it wasn't understood that we thought that when Greenland had clouds that the melting would slow down, that when bright sun was hitting the ice, that the melting would increase. And they found that it was the opposite, that the clouds, even though they blocked the direct sunlight, trapped heat because it's infrared heat, okay? And so as an example, it's a bit counterintuitive, right? Let's not get too detailed and sophisticated here, but he's absolutely right that the formation of clouds and the movement is a factor, but it's nothing we can predict and model because of its complexity. So it's not fair to say that, like the Greenland example, which we've discovered now. So I agree that clouds are part of the equation, but to keep simple on what we know, and we can say cause and effect, okay, with clouds, I think we have to kind of hold that off. Okay, how do I handle climate deniers? There's different flavors, really. If somebody's really confused, you show them the facts, some of these things. And even a lot of people who doubted climate change was caused by man, when they see that graph, the green, red, blue graph, and some other facts, and the ice ages when they were, a lot of them actually come around, say, oh, I didn't understand. I didn't know science knew that much about this. There are some people who just don't want to believe. That's fine, have a nice day. We don't need everybody on the planet to believe something, whether it be that women should have the right to vote, which certainly gets back to the roots of we don't need them all to believe that. We don't need everybody to believe in gay rights or civil rights or anything else. We just need enough of a majority to decide what the protocol and policies will be so that the rest of us can move forward. And I think we have to be realistic about that. There's nothing on this planet that 100% agree on. Great question. What are the top technological advances that will mitigate these effects? Well, there's a couple of things that I want to, that's an opportunity to explain. First of all, the word mitigate means a couple of different things. It's usually used with climate change to talk about reducing the warming. And that would get back to the first thing I talked about of reducing greenhouse gases, primarily carbon dioxide, or which can be by driving electric vehicles or resetting thermostats and so on. There's also mitigation of storm surge and things like that and the effects of climate change. That's entirely different. And so we have to be, I don't like the word mitigation, frankly. It's too wonky and technical sounding. Slowing the warming is good. I think there's a lot of things that will help us to slow the warming, like alternate energy, renewable energy, solar, wind, and things like that. But we're not going to get there immediately. And even if we did, sea level's still going to rise. So I actually use sea level to say, listen, if the world went 100% solar and wind today, 100%, we're still going to get sea level rise. The oceans have already been warmed 1.5 degrees. The ice sheets are going to get smaller. They're not going to melt entirely, but they're going to get smaller. So let's work on the slowing, and there's a lot of technologies to it. Maybe taking carbon dioxide out of the atmosphere, carbon sequestration, or carbon capture and sequestration, burying it in the ground. There's problems with all of those ideas, though. But let's work on them, and let's work on the renewable energy, absolutely. But let's not use that as a way to stop us from starting to adapt to higher sea level, which is even if we did all those things. And there is no technology. I mean, we do great technology with computers and phones and things like that, and maybe we'll have better visuals and better information. But, go out to the ocean and talk to the ocean. If the ocean waves want to come and put you, knock you off the rocks, they're going to do that. And we have to realize that there is no conceivable technology that's going to push the ocean down, freeze the ice that is melting because it's too warm, okay? Heat is a substance, and we have trapped too much heat in this planet. We don't think of it this way. There's no such thing as cooling. You can't cool anything. I know that doesn't sound right. What you do is you move heat. There's a difference. You can heat something because that's an active act. You can burn wood and create heat. You can't cool anything when a refrigerator moves it to your kitchen, an air conditioner moves it outside, but you can feel the heat, right? And it takes electricity to move the heat, right? Heat is a substance. Cold isn't a substance. Cold is a lack of heat. We don't think of it that way. So the reality of it is that having trapped more heat in the planet, there is no quick solution to that. Okay, we can find ways to warm the planet more slowly. We can find building materials and ways to jack up buildings and barriers and lots of technologies like that. We can come up with great electronics that allow us to monitor what's happening in Antarctica and so on. But we have to realize we've trapped more heat in the planet. We've painted the roof gray. We put more insulation in the roof. Does that make sense? Oh, tipping point of attitude. I'm sorry, I thought you meant a tipping point of warming. Okay,
no,
so
I meant an attitude to address the issue.
I think it's starting, but it's going to be a continuum. You think about change of attitudes, as I say, whether it be gay marriage or anything else, it reaches its own tipping point, and it's somewhere between 10 and 20% is kind of an inflection point. And I think we're getting there. I think more and more people, in the weird weather that we're having, the heavy rainfalls and things like that, I think these are all contributing. Most of the denial today is either political or yeah. The question was, what is being done to move people away from coastlines? Well, I don't know if you want to be moved away from your coastline or not, but I think most people faced with reality, particularly with something that's going to happen slowly, and the more you think about it, it's unarguable, they're going to do something. Okay, is one. There are places from Shishmaref, Alaska to there's an Indian town off of New Orleans or Louisiana, where the government's spending $50 million to move 50 families in both cases. So there's some specific efforts, but that's not, in the Chesapeake, there's places where we're lifting houses, but that's not scalable. I mean, there's a billion people with houses in a vulnerable zone. There is not enough money on the planet to pay them to do what you think they should do. But fortunately, this is going to take time anyway. And at some level, even the poor people of Bangladesh realize that as their house floods more and more often, they are going to find a way to move to higher ground. Now, the good thing with sea level is it's slow. The place where they kind of hit limits are out the islands in the Indian Ocean and the Pacific, the Maldives, Tuvalu, Kiribati, and the Marshall Islands, where they're just running out of land and they're going to have to relocate. And they're applying for loans or grants and territory in New Zealand and Australia. And there's some interesting discussions that'll happen, certainly, over the course of this century, okay? But it's really hard to get your head around this, okay, that the shoreline is going to move permanently. Now, if your question is interesting. What are we doing to move people, okay? I like to think that if you know that sea level is going to be 10 feet higher this century or next, and hopefully next, not this century, but that for your kids and grandkids, or maybe yourself, that you're going to move. It'd be pretty stupid if you didn't, okay? So we have to inform people, but we have to educate ourselves. First thing we got to do is get the facts right. The problem at the moment, and I didn't mean to insult you at all, I don't think you're stupid at all, but the fact is if we educate voters about the clarity of this, people will act. I mean, the good news with sea level is it's not going to knock you over like a wave, like a storm surge. It's not going to come up suddenly in 3 hours like the high tide. It's not going to, it's not going to be like a tsunami. It's not going to be like an earthquake. It is slow. I mean, you can crawl out of the way of sea level rise, okay? But it's a different change. It's an attitude about the shoreline. We thought the shoreline was permanent. We now know that it wasn't, and that we've actually kicked it back into the growth mode when we should have been entering the period when sea level was going down by nature. That's a revelation. We didn't see that until recently. Let's be honest and fair to each other, that if sea level had not changed in 5,000 years to speak of, means the shoreline didn't change much. The fact that we're having a lot of trouble believing it's going to happen is understandable, right? And let's be just fair to ourselves. I mean, there's a lot of denial, and forget the politics or the petroleum industry or coal industry. I mean, there's a lot of resistance to believing that the house your grandmother lived in New Jersey where Sandy hit, or in Miami Beach or anywhere else, is going to change. We didn't believe that the shoreline moved. It's going to take, I think, a generation to really accept that new reality. It's a bold concept. Yes. So the question is, as the ocean rises and what they call saltwater intrusion gets into the porous limestone here, which will affect the drinking water supply, what do we do? Well, the truth is there's not an easy answer for that, except that we probably will at some point desalinate a lot more water, but that's problematic too. There are many effects of rising sea level. I don't think that the population of the state of Florida is going to grow for decade after decade forever. I mean, I think that at some point as the ocean rises, we're still in this growth mode mentality that it's good for tourism, it's good for economies and home building and so on. We've always believed that more growth, more density was inevitable as populations went from 4 billion to 5 billion to 6 billion, now we're at 7, and we're headed to 10. The idea that sea level will be several feet higher and move the shoreline inland, or certainly try to, really changes everything. But that change is going to unfold over the next couple of generations. So the question of drinking water supply and how much we need and where we're going to get it from, there's a technology. I mean, there will be technologies that will produce fresh water with less energy than normal desalination, but then there's the problem with desalination. What do you do with the salt, the brine, which is an equally big problem? So none of these things are, what? Okay, that the quantity of salt is enormous, and all of these things are complicated. So is life. I mean, so's, you know, and there's the population component, and there's going to be military aspects, national security aspects. I mean, you can't change this many boundaries and resources and things like that. I mean, we are in for a very strange period. Now, again, climate did change naturally before. We didn't understand it fully, but now we've triggered it. Okay, good question. So why should people that are not coastal people that live on lakes care? Well, and most lakes are going down, by the way. They're not going up. It's the opposite. And they're going down because either evaporation, warmer planet, they're going to have more evaporation again, or we're drawing water out of the ground for irrigation, pumping groundwater out, so it's not getting to the lakes, is another reason, or meltwater from glaciers and things like that. So most lakes in general are getting lower, which is an easier problem to cope with. But the first person that bought a dozen of my books, actually back in about a month after they came out, was an address in Iowa. And I thought, you know, what is this? And I called the guy, and I said, why do you care about sea level rise in Iowa? He said, well, first of all, you know, we're farm country and all that, but we ship grain out through ports. And just like we pay attention to the El Niños in the Pacific because it affects the rainfall patterns, and which affects agriculture. You know, farmers today are pretty savvy. So they're concerned about the changing weather patterns, what it's going to do to shipment of grains. Okay, and they come to Florida in the wintertime. You know, people aren't bound by Kansas or places like that. So people are global. People from Denver and Switzerland, they do go to the coast, okay? But shipping happens at ports. And if you want to see disruption in the economy, you know, wait till you start looking at disruptions as ports become unmanageable. The planet's going to be very, take still a few more questions, but the planet's going to be very different. You know, we've always thought things will just get better, technology will be better, we're going to, you know, life will be better, and we're going to have more, we're going to take care of the poor and feed the hungry and use our cleverness and our technology. You know, some people believe we're coming up against some limits here, and that we headed from 7.3 billion to 10 billion, that we're hitting some carrying capacities. Now, that's a controversial concept, but I think we have to be realistic. The world has gone through lots of challenges, whether it be plagues, whether it be, there's been volcanoes that have caused volcano weather 100 years ago, a huge volcano changed the weather on the planet. I mean, it can happen naturally. We're going to go through an era that does not follow what we'd like to have happen, okay? We're going to have to wake up that technology doesn't solve all ills, just as it doesn't in medicine. We have great medical technology, we can't keep everybody from dying, right? We don't understand all illnesses. We have to realize there's some magic here, and there's some things beyond our control. And in this case, we now can connect the dots. As you can see, they're very clear that carbon dioxide and temperature go together, that sea level goes with them because the ice gets smaller. The temperatures in the ocean is overall warmer than it was by about 1.5 degrees Fahrenheit. The thing is, as you warm the ocean, the currents change. And so, and because of that, and the melting ice around the North Pole, the atmospheric currents, the jet stream changes. So one of the effects that I didn't mention, so thank you, is that not only is the ocean temperature rising, but one of the reasons the weather patterns are changing is because the normal locations for the jet stream and the Gulf Stream, they're all starting to change a little bit, which is what happens when you crank up the heat. You put a pot of water on the stove and you crank up the heat and look inside, the currents are going to start changing as you put more heat in the system. And that's starting to happen. Now, it's small amounts, but it's enough to make a big difference. the question is, if it wasn't for man-made warming, would we still have ice ages? Oh, absolutely. If we hadn't warmed the planet this degree and a half Fahrenheit, roughly, by burning this much fossil fuel so far, forget what's coming ahead, we would have been entering the 80,000 year fall to the next ice age, which is why there were conflicting signals about 50 years ago, and some people said the glaciers were growing. There probably were some signs of that. I mean, if you go back to, this chart, the question is, would things have gotten colder if we hadn't done that? And the answer is, I think, almost certainly yes. This is a natural cycle that's based upon 3 different planetary cycles, the change in the ellipse around the sun, the tilt and the wobble, and those 3 things come together about every 100,000 years, which is why we get ice ages. What's ocean acidification? Really important to clarify. So you may remember from school the pH scale. The 0 is super acid and 14 is super alkaline and 7 is fresh water, which is right in between, neutral. It's neither acid nor alkaline. The oceans overall have had a typical alkalinity of 8.15. They've been that way for a long time, after the stabilization and the life forms and things we referred to earlier. The pH is now down to 8.1, which doesn't sound like a lot, but it's a logarithmic scale, and that's about a 30% increase in acidity. That's why they call it acidification, okay? It's actually a decrease, it's less alkaline, but it has the same effect. So the problem is twofold, that plants thrive in a certain zone of pH. You know, if you want roses to grow in your garden, you've got to watch the pH of the soils. So as the ocean's alkalinity changes, it's a problem for the base of the food chain. The other problem is that there are some chemical factors in the ocean, like the formation of coral reefs and seashells, that are purely chemical based upon certain pH levels. At a certain level, shellfish won't form. They can't, because the cementation that's happening just can't happen chemically, okay? And it's already beginning to manifest up in the Pacific Northwest. The oyster fishery, which is like a $100 million industry up there, is having problems because just bringing in the seawater into the tanks is it's not alkaline enough. And so it's the first signs of how the lowering alkalinity, lowering pH, which is acidification technically, but it's not acid yet, it's just less alkaline, is a real problem. And in fact, in terms of problems for the planet, the ocean acidification, this thing of changing the ocean's pH, is probably more profound than sea level rise, because it changes the ocean chemistry. And it happens for a very simple reason, that carbon dioxide, which we're freeing up by burning the fossil fuels, the 400 parts per million there, carbon dioxide dissolves in liquid. When you uncap a soda bottle, you're reducing the pressure of carbon dioxide above the liquid, and so the bubbles come out of solution, right? We've all done that experiment at home. And when you put more carbon dioxide up in the airspace, it's going to slowly, not dissolve, but permeate the liquid. And carbonic acid from carbon dioxide is what seltzer water is. You can taste the slightly acidic fizz, right, in any seltzer water. That's carbonic acid, very mild, and that's what we're doing to the ocean. So the acidification of the ocean isn't a complex formula at all. If you put more carbon dioxide in the air, it's going to do 2 things. It's going to trap heat, and it's going to slowly dissolve in the ocean, or permeate the ocean, not dissolve, and that is going to make the oceans less alkaline. Good question. What is the Coast Guard's interest in Greenland? Well, let's see. There were 3 reasons we went to Greenland, and that was the commandant, that as the Arctic seaways open up and the shipping is going to happen across the Arctic, the Coast Guard has to be prepared for rescues from Alaska through the Canadian Arctic and so on. So that's one. And the problem is, as we talked about, is that, or I already mentioned, is that the cruise ship, which is already going through it, presents a problem because there's more icebergs than ever. And so seeing where that's happening was relevant for the commandant. The second thing is that the glaciers of Greenland are ground zero for melting ice on land ahead of Antarctica, and really makes it clear when you see the scale of this why sea level has just started to rise. But it is so, Greenland is so big, it's 3 times the size of Texas. It's 20% the size of the United States, including Alaska's landmass, 20% the size of Canada and so on. It's huge, 2 million square kilometers, okay? And there's only 56,000 people, less than in Boca Raton. So it's very low density, but 80% of the island's covered by ice right now, but it's getting smaller. So seeing that firsthand and appreciating just how serious that is was worthwhile. The other thing, and then realize that as the Arctic opens up, it's going to affect world weather patterns, and that's the third message. And then the fourth reason that he went there was to deal with his Danish counterparts who run the Coast Guard for Greenland, to deal with cooperation agreements about rescues and all those things. It's a great question. I get it all the time, and the truth is it depends upon your circumstance. Depends on your age, depends on how much you have at risk, depends on, you know, if you think you're going to live in that house for another 10 years and you don't mind an odd extra day of flooding over what you'd have now, don't worry about it. But if you have a house in a low-lying area that you plan to leave to your kids and on to your grandkids, and it's a big part of your net worth, you should probably think about when is the time to sell that or to do something. But that's a personal decision for obvious reasons. The good news about sea level, there's no need for any kind of mass exodus. And there will always be people who want to live here until the last possible time, okay? And that's fine. I don't believe the government should move people. I think we should inform people. I think we need to stop having subsidized coastal flood insurance or phase it out. I think we need to stop telling people that if they do get wiped out that the government's going to protect them, because and phase that out. Because the fact is it's not possible to do it indefinitely. But we had this attitude that we could protect people, and it was possible until climate changed and changed the shorelines. Things, she asked about the mortgage, things will change because the cost of insurance is going to go up at some point. And at some point the rules of the mortgage industry will change. You may not get a 30-year mortgage, maybe you only get 10 or 15-year mortgages. So there will be some, pardon? Yeah, there will be some changes. I mean, it's inevitable. Again, we never considered that the ocean will be 10 feet higher. It will be, hopefully 2 or 3 centuries from now. But there's no guarantee it's going to take that long. And that's a real concept to get our heads around. It's just fact. So there are going to be a lot of adjustments, but a lot of education. And we've got to get political leaders who are willing to speak the truth. That's a good question. How high will it be in what do you say, 10 years? 10 years from now. We can't melt the ice that quickly for about 20 years. It can't get that bad. I mean, we could get maybe a foot, back to that diagram before. The really bad stuff is probably at least 20 years away. I'm not saying it will be really bad in 20 years, but there's some things in Antarctica, some structural things that I just don't have time to get into here that indicate that it's where the glaciers are and where the bedrock is and some other fairly technical things. But if you look at the amount of ice that can move into the sea, like extra ice cubes in the glass, we've probably got 20 years before anything radical can happen. But that doesn't mean that year by year we're not going to see more flooding streets and things like that from Miami Beach to Norfolk to all over the world. But the really bad stuff is probably mid-century. And then it's hard to predict whether it's 1, 2, 3, 5. It's hard to tell. 2 things. First of all, the term 100-year flood and 500-year flood are really misleading. It doesn't mean that's how often they happen. It's an inverse to an estimate of the probability of that flood in a given year. So a 500-year flood is when they think that there's a 0.2% chance of it happening this year, okay? It sounds like the same thing, and in a way it is, but in a way it's very different. Because you can get 2 500-year floods in 2 years, okay? The odds are against it. But we're getting them more and more. And why? Because we're getting more moisture in the air. And the problem is, and most people don't explain it this way, is the probability is based upon the track record. And as the oceans warm and there's more moisture in the air, the truth is we can't predict how much rain we're going to get very well in the future. And all of those descriptions of 100-year floods are kind of out the window, okay? And unfortunately, the meteorologic sector hasn't quite come to grips with it. They don't know what to replace it with. The insurance industry as a whole, there's a group, a reinsurance industry out of Switzerland called the Geneva Association, and they published a paper in 2013, I think, that said that, you know, really follow, and this is the 90 companies in the insurance industry in Switzerland, that following the ocean heat increase, that this is going to change everything. This can change the weather on the planet, the incidence of disaster events, and that the insurance industry is a profound problem because the insurance has always been based upon long-term probability and pooling risk and the statistics, the actuarial data, right? Lifespan. Pardon?
Completely unpredictable, right?
Well, it's not completely unpredictable yet, but it's going in that direction, that we can no longer predict the future based upon the past. And there was a recent U.S. government study out of the Defense Department which said the same thing. We can no longer predict and then act. We have to start thinking about extreme scenarios. And that's a profound concept. Engineers are not used to doing that. It's like, let's take lots of measurements and then based upon that, know what to build next. Well, even the Dutch have hit the wall on this, no pun intended. They've been really good for about 1,000 years of recovering from land from the sea, and since 1953, when they had a terrible storm one night that killed 1,835 people when a levee broke, they built all these great coastal defenses. But even the Dutch, when you know, you've seen pictures of the big harbor gates in Rotterdam, called the Maaslandkering, and when those gates, which cost about $800 million to build, they were the crowning jewel of the Dutch coastal defense system. They now realize that they didn't build them high enough because of sea level rise. They planned them for 1 foot of sea level rise, and yet they built them for a 1 in 10,000 year storm and the worst river flooding, but they underestimated sea level rise. So it gets to the point, it's really hard to design for the future, but we need to think bigger. And even though the Dutch have great engineering, they badly underestimated sea level rise in 1980 when they designed those gates. There's one of the simplest fallacies we have is to think of sea level rise like a storm surge on the coast, because people say, well, I'm 5 miles inland, I'm safe. You're on low ground. You're near the Everglades, okay? You only need a few inches to get to your doorstep, okay? And it's counterintuitive, okay? Storms are waves crashing on the beach. Sea level will come up through the porous limestone here no matter where you live, and elevation counts. And high tides, I think I skipped over this, it's an important point. Extreme high tides every 28 days following the pull of the moon and the bulge of the, and certain months of the year when the planets align, these extreme high tides are predictable to the minute to the inch by location, the tide tables. So you have a totally unpredictable storm. You don't know how, when, where it's going to happen and hit, but it's localized. You have a totally predictable tide cycle according to an 18.6 year cycle that has to do with the planets, that we can tell you exactly where it's going to be, how high. And then you have sea level rise, which is neither, because it's the reflection of the amount of ice that melts over the long term. And the height of the ocean at any one moment is the combination of all three. And it's, no scientist can tell you what it's going to be like 20 years from now, because we know what the tides will be, but we don't know what the base sea level will be because we don't know how much ice will have melted. And we don't know when the next storm will happen and whether it's going to be worse or more frequent because of the warming temperature. So we are in a new era. And, you know, but that can be, you can think of that like terrorism, you can think of that like Zika, you can think of it as AIDS, you can think of it as food supply, GMOs. There's lots of challenges. And the only thing I would say to you, I mean, I have a 15-year-old daughter, and it's one of the things I certainly thought of as I was writing my book and doing my research, is there's always been huge challenge. We just somehow deluded ourselves into thinking that by our cleverness, we could get rid of risk and unpredictability. And so it's kind of a philosophical way to think about it. There have always been those, I grew up with, nuclear bombs, many of you, we thought that was going to be the disaster, right? Now we worry about terrorists, okay? This is a different kind of risk because it's slow and permanent, it's going to change the shoreline. But that's, not to be silly about it, but that's part of life and challenges and how do we adapt. I mean, you can look at it lots of different ways. If you go back through history, there's always been some new terrible crisis that nobody had ever experienced before. This is a different flavor. There's, Elon Musk wants to put 50,000 people on the planet Mars by the year 2050. Okay, this is new territory, but our adventure on Earth has always been that. And it's just a matter of starting with the right facts and perspective and then sharing it. So. We're going to lose a lot of assets as the ocean rises. Trillions of dollars, which is terrible, and it's sad and so on. But you know what? We're going to create that much value as well, because whatever has to occur for people to relocate, or either elevate or go on floating structures or move inland or do something else or move to Mars, we're going to have to create the same amount of value as we've lost. So if you think of it, it's a zero-sum game almost, okay? So it's an interesting way to think about it. So you can either lament that the land is going to flood, whether you're on the Mississippi and you know it's going to happen for centuries, right? Or you can say, wow, the ice wasn't going to melt like this before. I mean, it's a problem, and we should try and slow the warming. I don't want to give up on that at all. We absolutely should do everything possible to slow the growth of greenhouse gases. Don't misunderstand. That is absolutely true. It's the crisis of the planet. But while we're working on reducing greenhouse gases, we should start adapting to higher sea level. I truly end everything, my TED Talk and my book and all my lectures by making clear we have to do two things at once. It's not one or the other. We need to slow the warming as quickly as possible by policies that price carbon in some fashion so that there's a broad-based economic incentive to get off carbon. I believe that. And that's not a political statement. And then two is we need to wake up and realize the ice is going to melt. We don't know how quickly, but regardless, let's start figuring out how to build higher. That as sea level rises, that whether it be Florida or New York, that we're doomed or something, and we can't move away from the shoreline. But so let me try and just put something in perspective here. First of all, New York is not at all similar to Florida. It's not New York is not at all similar. New York City, Manhattan is not at all similar to Florida. It's very different. It's very different. It's a steep island, not beachfront, and it's granite. It rises out of the two rivers. It's not porous limestone. New York will be there for, I think, a couple of centuries. Manhattan, okay?
Why?
Because it's granite, and the lowest point is 5 feet above sea level. Okay, Miami is the tallest point is 5 feet above sea level, and it's porous. They're totally different geologically. They're almost opposites. But to your bigger question, can people move from the shoreline? I said sea level has risen in the last 150 years 14 inches in New York.
Okay.
Compared to the 46 inches in New Orleans and the 4 inches in Los Angeles, New York was 14 inches, okay?
It is 5 feet above sea level.
Yeah, the low, I believe from recall of during Sandy and Hurricane Irene when they hit that the lowest part in the battery is about 5 feet above sea level. But that's easy to fix with relatively easy with a seawall because it's solid rock, it's granite. But the point is, even though you say New York's the best city in the world, and I'm sure people in Hong Kong, London, okay, yeah, I understood your prejudice. That's okay. But whether it be Hong Kong, Mumbai, Shanghai, Tokyo, Jakarta, lots of people think they're in the best, or Seattle, most people think they're in the best city in the world. the fact is it's all going to change. But it's not just the biggest cities. It's Jacksonville, it's St. Petersburg, it's Naples, okay? It's every coastal community in the world, and not just on the coast. It's up through marsh areas like Savannah, Georgia, like on rivers, Hartford, Connecticut, and Sacramento, California, are on tidal rivers, okay? So thank you for making me point that out. I forgot to point that out. This is not about the big cities that are on the ocean. Washington, D.C. and London are not on the ocean. They're both on tidal rivers. They're highly vulnerable to sea level rise. So the problem of rising sea level has very little to do with Manhattan, is my point, okay? Besides reducing CO2, is there anything to reduce CO2? There's nothing I'm aware of that's been proposed. The idea to change the chemical composition of the oceans or somehow get carbon dioxide out of it, I've never heard of any plan for that. So,
Thank you.
Thank you.
Books, yes, please, buy your
We'll
books.
sign some books if anybody wants. The other thing, for those of you here, we do need to inform elected officials. We need to enlighten them so that all green issues aren't the same, and I hope the league can find a way to, take this to Tallahassee.
You're fabulous, you truly are.